Okay, I'd like to introduce you to our final pre-lunch entertainment talk from Tim Couper. Again, I won't read the slide. Tim's been an avid Python user for a long time, and he's a great bloke. And he's going to tell us how circular imports work. No, he's going to tell us something about Python references.
Want to. Well, let's go like this. We're going on a bit of a voyage of discovery today. What we're going to do is we're going to find out what Python references are not and what they are. We're going to find out about what weak references are and when to use them. And we're going to find about circular references, how to spot them, how to avoid them, and how to resolve them. And it's kind of going to be interesting. Learning a language is it's like someone arriving from kind of outer space on the Earth and trying to work out what gravity is. And it's sort of anything that falls to the floor, and if it's got butter on it, it's downwards. And then they see that you've got, well, these birds things seem to fly, and so that doesn't seem to work, and candle flames go upwards, so we kind of build rules in our heads about how it works. And it's quite similar with Python, I've observed, because the language is kind of natural, and we just write stuff, and it works, and we don't really think about it. The motivation for proposing this talk originally was I had the unfortunate experience of having, within a course of just 1 or 2 weeks, having some presentations made. First of all, a developer was saying that he's got some bugs in Python because it doesn't do what he expected. I had a book to review, which is a Python book, where the explanation used was completely wrong. And I was in a Python presentation by a firm that actually used Python. It was a technical presentation that I was auditing, and the guy just explained it wrong. And I thought, well, if these guys are explaining it wrong, and I didn't get it right first time, there's probably lots of people out there who are more confused. Now, I'm going to confuse you first and then make it nice and simple with some animation. So let's go on this voyage of discovery that people have when they come into the Python universe. First thing they do, they write themselves a little list, and they find that that is the case. So they go, aha, we're not copying, this is a language which does references because B is A. Okay? We all understand that? Are we still here? Yeah, good, right, okay. So on I go and I write some functions, and that's the function. Yeah, okay, looking good. And I can run the function and it works, okay? Are we all happy with this? Is this too difficult for us? Good, it's not, right, good. So I do the same sort of function with a list argument, and that kind of works as well. So I check that the output from the list function is the same as the stuff thing that went in, and I found it was true, and I feel comfortable because I was taught about references at university, and I know all about references, so we're on a roll. So I better check that plus x is passing by reference as well, okay? So I put it, when it comes in, I just want to check that it's the same. And it is. Okay, so everything's passed by reference, so I've now got a handle on Python. I know what I'm doing, right? Then it becomes a bit unglued, because if I do this, and I have the same function, and I pass the A in, and I do that, and it actually isn't the same thing as A, but it was before, and it isn't now, so I'll start making up the rules, like the flames, like maybe birds fly because they got gravity doesn't apply to things with feathers. That's what it is. Or if it's hot, gravity doesn't apply. So I go, and Alex Martelli tells me, because he's a star, that actually this problem you're having is because ints are immutable and lists are mutable. So what's your problem? Well, you stupid boy, go away, right? That's why it's all wrong, right? So then I start, okay, well, that sounds fine. So I go off and I'm writing some more code. Then I get this kind of situation where I'm writing a function, and I've got plus x, which takes a class in, and it does this. And it behaves differently again, because this isn't immutable, this is mutable, and it's all a mess, and I don't know what I'm doing. And I don't understand it, because my gravity model is wrong. Okay. So, but as a last-ditch hope, maybe Python references are like pointers in C. So, I can do that, and yes, it is. Okay, so things are looking good, because A is the same as B of 0. Yeah, so it's the same thing. So I'll just do that, and oh, rats, it isn't. I change the value of A, and then B of 0 doesn't know anything about it. So that's not right either. So now, is Alex Martelli wrong? No, I'm sure not. So, and then you go along in the world and you find more corner cases, and you live in a muddle, and you're not quite sure what's going to happen. If I use this thing in a function, is it going to be like that? Or if I do that with it, isn't it? And it's something about mutable and something about immutable. And so when does this matter anyway? So as you can see, my coding's really interesting, right? So, now, as I said, this appears to be actually a common experience. This kind of journey is a common experience. And actually, here was a real case. Was a developer who was at the it's passed by reference stage. He defined a class A, defined a class B, and in the class B, he defined a change method, because self is a reference, right? Self is a reference. We've all agreed self is a reference. So what I want to do is I want to make self an instance of class A, instead of being an instance of class B. So what I do is I instantiate B, I change it, and I check to see whether B is an instance of A, because I've done the assignment there, right? Because I believe in references. And of course it isn't. And he couldn't understand why this didn't allow him to change the nature of the class, right? Are you all saying this boy's stupid up here? Why am I sitting here? Why am I not going for lunch early, right? No. Is this good? Is this a problem anyone's had? Am I just talking into the ether here? Maybe it's just good. That's great. Oh, Alex, you're here. I didn't even know you're here. Oh, sorry. No. Great. Oh, now I'm in trouble now. So, to help sort this problem out, I've invented the visual reference engine. Okay? Now, this took a little while, and I'll see if I can do this with one hand, which could be easier said than done. Here it is. Now then, you can see the visual reference engine. It's pretty simple, really. Let me show you how it works. If I, okay, you see that? You do assignment statement, right? What happens is the Apple instance gets created first. And then the A says, I know where Apple is, and I'll just point to it. And the Apple knows how many references it's got pointing to it, because it's got a count here. Okay? Shall we do that again? Yeah? Okay. But you've never heard. That's the first time that as you can hear things being created in a Python environment. It's quite amazing. I'll just do that again. Okay. So now it's quite a useful little engine because that tells us something, and then if you delete the name, the name goes away, and the apple, which was sitting there, has got no references left, so it says, not interested anymore, I'm out of here. And it just disappears, which is what it did. Is that right, Alex? That's good. I was worried there. Oh, there's another one here. Okay. Now, so let's just do this with two references. Okay, so we've now got two references to this apple, A and B, two names, A and B, and, as you can see over there, the apple thinks it's got two things pointing to it. It has got no idea what they are. All the apple knows is that there are two things referring to it. It doesn't know whether it's your code or a C module. It just knows that there are two. And A and B, of course, know what the apple instance is. And when you delete B, one of the references goes away. And when you delete A, it all disappears, just as if they go out of scope. Okay, let's go back to where we were. Is that all right? Are we all getting this? Is this all good? Right. I've deliberately written all the stuff on the slides so that when you get the slide set, you can. So, just the point at the bottom there. Names are deleted when they go out of scope, so it's not necessary to explicitly do the dels. So when a name goes out of scope, it says I'm not interested anymore, and if all the names go out of scope, the object goes, no one's interested in me, and it disappears. So, assignment is merely naming, nothing more. In fact, you could say name it and claim it, right? Name it and claim it, name, and you can claim it, right? So, let's look about a quick look at changing claims, changing things that things point to. And let's go. Used to our apple here. There he is. And there's B. Now, the first time that a list is going to be shown in public, it hasn't been seen before. This is the first time you're going to see a list. It's in Microsoft. It's a Microsoft list, so I mean, it's built on a Microsoft platform, so I tried to get it in actually blue screen of death blue, but you can't really see it against the background. So there is a list, ladies and gentlemen. And you see, C points to the list. Okay? Now, what we're going to do is we're going to say B is now going to be a reference to the list. Voila. Okay? So we can look on the right-hand side, and we can see that there's one of these, and there's two of these. And you can't do this in PowerPoint. You can move them all around and do what you like. Okay. Okay, so end of file. Everything, all the names go out of scope. All the objects say, no one's interested anymore, and they disappear. Okay. And that's about all there is about references. Because once you understand that, you understand it all. If you want to know how many, the number of references an object has, you can call sys.getrefcount. And if you call sys.getrefcount again, then yes, it's one more than the actual number of references. I talked to Guido about this. Why don't they return the number of references? But it seems it's too hard. Now, there's probably a more detailed answer than that, but it seemed to me a bit trivial. But hey, what do I know? Okay, how are we doing? Not bad. Weak references. They're not references that haven't been down the gym. They're actually things that are quite useful. But where are they useful? Well, how about a use case for this? A use case would be, I have data that I'm also caching in memory as a list. Okay, so I've got a cache list, and I've got a piece of data. And when that data is deleted, I don't want the reference to exist in my cache. Otherwise, I've got to keep going around, delete, if this is deleted, then I go and delete that, and you've got to write these extra bits of code. Okay, so here's an example of code. That is, if I create an apple, and I create a list, and I append A to that, and we delete it, the A ain't going to go away, because there's a reference to it, isn't there? Do you want to see that? Let's just do that. Okay? Okay, now here we have, you see, the representation of the first item in the list of A is pointing to the apple, right? We happy with that? Can you see it over there? Are we still awake? Is it good? Is it nearly lunchtime? Right. When I delete A, you see the apple says, I've still got a reference, so I'm not going anywhere, I'm staying around, right? And that's exactly what I didn't want to achieve in this. Now, of course, when we go to the end of the file, everything goes away because all the names go away and everything disappears. Okay? So, here's some code to show how weak references behave, and we'll just demonstrate that in the engine. It doesn't know a lot else than apples, to be honest. Okay, now, you can tell it's a weak reference because it's green. I bet you nobody ever knew before that weak references were green. but it's a weak reference to green. You'll notice on the right-hand side, it's got a blue reference, so the apple knows that it's got one reference and it's got a weak reference. Okay? Now, when I delete the A this time, it disappears because no one's interested anymore, and the weak reference references good old none, which is sitting around and has been sitting around there waiting for its part in the performance. So let's do that. In the caching example, okay, this is what we did before, if you recall. Now, what we're going to do this time, we'll do one more. So you'll see now, we've created a weak reference, which points to A, and we've also got the first item in the C list also points to the apple A. The apple, sorry, points to the apple, yeah? Are we happy with that? Is that good? So what's going to happen if I do del A? The apple's going to go away because it'll go down to 0, say I'm not interested anymore. I'm going to go away. So, okay? And that's the use of weak references. Everything goes away. Okay. So let's go back here again. So finally, we'll just get the actual reference of a weak reference, because that's always a useful thing to be able to do. So there we go. So that we've got a weak reference to A, and if we know we've got a weak reference to the apple. If we want to know what the actual reference is, because I want to use it for something, I can just call the just call the weak reference, and that gives me the actual reference. And then I can delete A, and it behaves in a manner to which you'd expect. Okay? And that's all there is really to say about weak references. Except to say, if you want to know how many weak references there are, you can do get weakref.count, and that will tell you, and it doesn't. It gives you the actual number. And it also tells you the list if there's another useful function if you ever need to use that. Okay, how are we doing? Is that all right? Do you feel you understand how it works? Has anyone actually found that is insightful, or did you say, oh, I knew all this anyway and I don't know what I'm doing here? Was it good? Was it good? It's helpful. I mean, to be honest, I was joking about Alex, but Alex talks about this at EuroPython. He alluded to this about 3 or 4 years ago, and a little light went on for me, because it was just because unless you hear about it, you don't know. Okay, circular references, those things like circular imports, except I understand circular references. Right, here's a circumstance in which a circular reference will arise. Oh, let's draw it. It's much easier than explaining it. Okay, we have a list B, and we have a list A, okay? And then we're going to have the first instance of B reference A, and the other way around. Okay? You understand that? Can you all see what that's supposed to be saying? Good. So I'm now going to delete B and A. And unfortunately, neither list disappears because it thinks it's got a reference still, but actually those references aren't accessible because you can't do anything in the namespace because B is gone. So you can't do del B of 0 because it'll say what's B. Okay? Yeah? No? Okay? That's fine. So that's basically what a circular reference is. You probably knew that anyway. But you've just not seen it done that way. Okay. And the way to resolve this is because good old Python has a garbage collection routine to remove them. And it runs it periodically. And it's just as an aside, it's quite interesting in the embedded world, at least, to know that it can be turned off, because if they know their code does produce no circular references, they want to know that when a name is deleted, that the object has gone. It's not kind of hanging around waiting for something to get rid of it, because there's often memory issues. And they don't even want the overhead associated with a garbage collection routine. So you can use the GC module in your code, and that's what actually happens. If you run that same code we ran, and the garbage collection will nicely pick up 2, and everything will be nice and clean and clear. And if you've got some circular references, this is a good place to start if you're trying to seek them out. There is unfortunately one type of circular reference that you can't collect, and that is when one of the objects in the reference list has got a finalizer, spelt the British way. It's probably a finalizer over here. That means it's got a del method. And to help you with getting into resolving this mess, gc.garbage does contain a list of objects, da-da-da-da-da, as it says up there. Okay? So, now when this happens, what can be done? And I'll give you an example from this about how we resolve the problem, or what you can do to resolve the problem. So, we collect and store and process large amounts of web-related data, and some of them form a tree structure which is of this nature, which you can see that if you instantiate one with another, you get the parent and the children being referenced by 2, as I will show. So, the structure is circularly referenced, and it's garbage collectible. But we wanted to remove the circular references and still pickle the tree. So the garbage collector would pick this up, but we were pickling it all, and then you're unpickling it, and the garbage collector has to sort it all out for you. So we said, let's get rid of this. Let's get rid of the circular reference from it. So here's an example of the code which you need to run, just to show that you get the circular reference. So I create a node instance. I say the parent of node 2 is node 1, but then that, because of the way that the initializer works, that becomes also a child of node 1. So you've got 2 parents, 2 children. And then if you run that program, you get gc.collect. And I shall go to the little demo here. And I shall run a little program here, and program here. Okay. Can you see that? Can you see this stuff here? So there's our little node object. Okay? Well, it would be a node object if we didn't have this. Excuse me. Right. So we have a node object here, right? Which if you run it, okay, here we go. I'm going to have to just take you through a little bit of code here, right? What I'm going to do is I'm just going to go through pick that node object, run the test of the node, which is going to do that N1, N2 thing, delete them, and then I'm going to garbage collect it, and then I'm going to pick up the garbage. Okay, so that's what it's going to do. And here is the test node program down here, which basically does what I said, okay? Apart from a little bit of jiggery-pokery, which says, whoa, fall off the stage, let's get back on. Stage not big enough. So I instantiate a node class instance, and then I instantiate a node class again, passing the reference through. I try to pickle it, and I delete them. Okay? That's what I'm going to do. So, I've called this. Okay. So, it could pickle them. It found 6 circular references, but it collected them all. Okay. That's cool. So, intrepidly we go on saying we don't want these circular references, so I can use my weak reference thing, can't I? Because I know about weak references. So all I've got to do is make this parent a weak reference here. Okay? Sorry. Right. Now, because I've got self.parent equals parent up there at the very top, all I need to do is to make a weak reference is create a class called woad, which inherits from that, and put this little pattern in here, which when it does a set parent, it actually makes it a weak reference. And when you get the parent back, you call the weak reference bit back. Okay? Can you see that? So I just change that piece of code up there, put this little bit in there. So when it goes in parent equals set parent, it actually sets underscore parent as a weak reference. And then when you get the parent back, it's going to return self.parent of open brackets, close brackets, which we know will give you the real reference back. So this basically will do the same as that. So that's good news, because that will actually break the circular reference, because then we won't, because we know weak references solve these problems for us. So, oh dear, over here, change the code again. Let's just add this chap to the little list. Come on. Okay, so I'm going to do node and woad now. Okay, let's save that and we'll run the program. Okay, so the good news is that we've got rid of the circular reference problem. The bad news is we can't pickle it now, because you can't pickle weak references. I'm sure someone should have fixed this. Oh, rats. So all we now need to do, halfway there, or have we just gone out the frying pan into the fire? Well, fortunately for my talk, we can do some magic to the woad class to make it pickleable by creating a pod class, which inherits from woad, so it behaves just like woad does, but actually as you go in and pickle it, just before you pickle it, which is the get state, it will set the parent to none. And when it comes out of being pickled, we'll just go and make it pickle it properly. And this is a really cool part of pickling. If you've never done pickling before, this is really cool. Using get state, set state does this magic. Okay? Trust me, I'm a doctor, right? So, back to our little program again. Let's do the pod one. And okay, so down the bottom here, you see, we can pickle it. We've got no circular reference, so we solved the problem. Okay, good. So we're all happy. Everything's hunky-dory. And finally, I just want to show the case, which is the case which is really hard, which is if you've got a finalizer in it. So I've got a thing called Dode, because it's got a del part in it, which just takes the node class, right, and it's got a simple finalizer which just says pass in it. Okay, so it's going to behave just like the node class does when we run it through the tests. And we go back to tests, and we include this in the tests here. Oh. Okay, so there's the Dode class, and I've also created a Dode clone class so we can see the output sensibly here. But it's just the same as a Dode thing, what it's worth. Let's just run this chat. Okay, so the first three we've seen before, the node one, the woad, the pod, and the Dode one. You can pickle it, 6 circular references found, but it can't sort them out. And then there's a really nice utility which will be available in the group, which actually prints out what the problem is, and it shows you the circular reference, and that's basically pretty printing the gc.garbage routine, and that's, if you want to bother to look at what it means, it basically means you've got a child and a parent, and both things have got children and parents, and they all relate to each other. So that's that. Let's excuse me. To finish with this one. Things you should take away with you. Assignment is naming. Circular references, nothing really to worry about. Just look carefully, independent classes with del. And if you want to look at things, look at garbage collect, gc collect, and garbage. And I will leave you rather hurriedly with that.
Yeah, I'm afraid we don't have time for questions, but you can harass him after and during lunch. So thank you, Tim.